My name's Ben. I work at the Bristol Robotics Lab, and today I was introducing a tactile sensor called the Tactile, which you can see here. This is what it looks like on the inside. It's got these white pins. When you touch it, the white pins move around, and on the back of the sensor you've got a camera that's filming those white pins, and it films the movements of the pins. So depending on how the pins move, you can tell kind of what to touch. Which is a really simple idea of using a webcam, standard webcam, to film and track pins on the inside of a deformable skin. I then went on to talk about how we're using this and integrating it on grippers, on these kinds of hands. And yeah, it went really well. So the kids seemed to enjoy it. There were a lot of very interesting questions. Partly on this, I got one or two groups who really seemed interested in it, and a lot of questions on robotics in general.
Okay.
About Skynet and Terminator style consequences of robotics, the ethics around it, which are always a little bit hard to answer, and a lot of questions about how soon till we can get this kind of robot.
Yeah.
Which, not always easy to answer, but I think it shows that they're interested in the field in general.
Yeah. Good.
And then there were some really quite focused questions on and sort of comments on the way this particular sensor works, which I was quite surprised by.
Yeah.
Really quite insightful comments on it, which took us a while to come up with. So
Hello, my name's Graham Mitchell. I work for Cryon Medical, which is a company that makes knees and hips. Today I've been talking to the children here about the knees and hips and how we make them, the materials we use, why we're replacing the hip or the knee, and how it relates to the robotic arm that they're trying to build in terms of longevity of the device, materials, the weights, how they could potentially take some of the knowledge they develop for the arm and use it into medical engineering later. Generally, the response from the children has been great. They've been really interested. They love to see a bit of the medical side of it in terms of how they can improve or change their bodies. Some of them like to think they can make some really fantastic implants. I hope they can, but that's certainly for the future. We're stuck with what we've got for the moment until they develop the next generation of things. So it's been great to have them ask questions like what materials we use, how long they last, what it is that we can do for people, the revision sides of it. Some of them have got operations pending and they're asking questions about what we can do for other areas of the body, so not just the hip and the knee. So it's great to see it.
Have you enjoyed it, Graham?
No, I've very much enjoyed it.
Yeah, good.
It's been awesome.
Yeah, excellent. Thank you.
Here to BT. We really appreciate it. Now, what we're going to be talking about is obviously our crane, the solutions we could put towards it, the ideas of how we can improve the design and the technologies we can use to improve it as well. So first off, we're going to have Matthew with the crane.
So when building the crane, we had multiple problems such as dowels breaking and the cardboard splitting, and this could impact further designs on the crane. We also had problems such as the pumps not being powerful enough, so we had to change the
So
bigger
by using
pumps.
hydraulics instead of pneumatics, that would have meant we didn't have to calibrate it, because the elbow joint because it's got quite a wide swing on it, sometimes you'd have to unplug it, give it a bit more air and put it back in. And that's because air can be compressed and water can't. So we'll use hydraulics, and that will mean we can use it for longer without having to maintain it. Although that would get the cardboard soggy if something were to happen, and the air is quite harmless.
We discovered that whilst building our crane, we had swapped some parts in order to make a more sturdier and harder structure. For example, some of the safety pins were swapped for staples. Some of the top head spins were also swapped for staples, as we thought that it gave it more of a structure and something more to hold on to.
Experience of working under pressure, so it should be.
But if we were to have this as he said, aluminium, or even in the future carbon fibre or things like that, lightweight material is always better because it means the only thing the crane is lifting is a load, which means a better energy conservation.
So have a higher range of heights changing for the crane, so that it can reach higher objects and obviously lower objects.
We found out that if we were to use string or something, it wouldn't be as good. And like an advantage of using these pipes is that they don't get tangled around them. Yeah, we were thinking like maybe next time to have like just a little toolbox on the tables and just like limited amount of stuff, just to say like, because if you lose a split pin, then that's your own fault. Do you know what I mean? And then like so other teams don't benefit
For
from
the
it.
grabbers, the grabber, we will have a tactile sensor so that we can detect when it grabs an object, so that it will stop automatically, but it still has a sense on how tight it's grabbing the stuff, so it won't slip.
Like, do it themselves. So, for example, like cranes with like feedback, so like touch or like camera sensors, like cranes with that can prevent less injuries and prevent less people operating them, so that they can operate
If I was to
themselves.
get an apprenticeship or something, a job along the lines of engineering, I'd like to bring that in, as I feel like it's a good way of recycling, it's a good way of getting the job done, and like it kind of, I could use that in the future in order to show that there's a cheaper way of doing things, because this could still pick things up. It doesn't need to be a really expensive model just to pick up something small. And I feel like that would benefit people and it would profit.
It could also be used for medical research as well, with prosthetics. People that have lost their arms in combat and stuff, or born with it, is a standard elbow, wrist, hand, arm, and eventually it could be even more robotic than this, so it could have sensors and actually made to fill.